welcome. Want to see videos relating to mathematics questions. Okay, so I want to start with the laws of indices. Okay, now before we proceed, we also have a YouTube channel where you can learn from the comfort of your home. You have a YouTube channel. We have also on Facebook, TikTok, Instagram. Okay, so you can check that out in the King's Tutor. You can type the King's Tutor in Facebook and also on YouTube, TikTok, and Instagram. Okay, please subscribe. Click on the red subscribe button, the notification bell, so that you can follow us and learn. Okay, so one will see question on laws of indices. Okay, now before we start, what are indices? Indices are numbers that are used in expressing the index notations. Okay, so the index notation is a short way of shortening number that have the same factor. For instance, if we have 2 times 2 times 2 times 2, it can also be written as 2 raised to the power of 1, 2, 3, 4. 2 raised to the power of 4. Okay, so this is seen as 2 raised to the power of 4. So indices are used to express numbers in powers. So in indices, we call this the power, or it is also called the index. Why this is called the base. Okay, so this is called the power, also known as index. Why this is called the base. In the same way, we can also have 5 times 5 times 5, which is written as 5 raised to the power of 1, 2, 3 as 5 raised to the power of 3. Okay, so it's called 5 raised to the power of 3. It means you multiply 5 3 times. Okay, and this will give us 75. So this is called the power, and this is called what? The base. So this laws of indices is one of the topics that's important in WAEC. It always comes out. Okay, and it relates to other topics in mathematics, which is the exponential equation, the logarithms, geometric progression, because the laws of knowledge of laws of indices is applicable. Okay, so we should pay attention and learn from this. So we want to see the laws of indices, because these are the laws in which, if you're not conversant with it, it will be difficult to solve indices related problems. Okay, so we want to see the laws. Now the first law is this. Now it is written as a raised by m times a raised by n equals a raised by n plus n. Now what it means is that if we have the same base and it is multiplication, you take one of the base and add their powers. Okay, so for instance, example, if we have 2 raised to the power 3 times 2 raised to the power 2. Okay, so since the base are the same, I'll take one of it and I'll add the powers. It will now be 3 plus 2, which is equal to 2 raised to the power of what? 5. Okay, and 2 raised to the power of 5 can give us what? 32. 2 raised to the power of 5, that is 2 times 2 up to what? 5 times, which will give us what? 32. Okay, the same way, that is the first law. It means that if you have same base and it is multiplication, take one of it and add your powers. That's the first law. Okay, another one is also a raised by m divided by a raised by n. Okay, so if the base are the same and it's division, take one of it and subtract their powers. Example, if we have 2 raised to the power 3 divided by 2 raised to the power 2. Now since it's division, I will take one of the base and subtract the powers. So it will be 3 minus 2, which is 2 raised to the power 1. 3 minus 2 is 1, which is same thing as what? 2. 2 raised to the power 1 is same thing as what? 2. So whenever the base is the same and it's division, you take one and subtract the powers. Okay, now the next one is a raised by n, all brackets raised to the power of n. It is equal to a raised to the power, the multiplication of n by n. And what it means is that if we have a value, a base that has a power, and all raised to the power of another number, it can also be written as the multiplication of the two powers. For instance, for example, if we have 2 raised to the power 3, all brackets 2, okay, this can be written as 2 raised to the power 3 times 2, which is 2 raised to the power of what? 6. Okay, so whenever we have something like this, whereby we have a power that has a bracket to another power, it can also be written as the multiplication. Okay, that's another law. Another one is a raised to the power 0 equals 1. And what it means that anything raised to the power of 0 equates 1. For instance, if we have 10 raised to the power 0, it equals to 1. 100 raised to the power 0 is equals to 1. Okay, 200 raised to the power 0 is equal to 1. So anything raised to the power 0 is 1. Okay, so the next one, the fifth one, a raised to the power of minus n equal 1 over a raised to the power n. Now what it means is that if you have an index that is negative, it equates the reverse or the reciprocal of the base and the index. That is a raised to the power n equal 1 over a raised to the power of n. For instance, example, if we have 2 raised to the power of minus 3, okay, since you have something like this, it is equal to 1 over 2 raised to the power of 3. 2 raised to the power minus 3 equals 1 over 2 raised to the power of 3. The same way, if we have 5 raised to the power of minus 2, it is written as 1 over 5 raised to the power of what? 2. So whenever we have an index that is negative, it is equals to 1 over the base to the power. Okay, so the next one, the sixth law, a raised to the power of 1 over n equals the nth root of a. Okay, and what it means is that, for example, if we have 5 raised to the power, okay, let's say 8 raised to the power of 1 over 2, it equals square root of 8. Okay, the square root of 8. Or another example, if we have 10 raised to the power of 1 over 3, now it's equals to the cube root of 10. Okay, so whenever we have something like this, a raised to 1 over a particular number, it equals to the what? The root. The denominator of that index becomes the root of the what? The base. Okay, so a raised to 1 over 2 becomes the root, and 8 is the base that is inside. 10 raised to 1 over 3 becomes the root, and 10 has the base inside. Okay, to get the what? The cube root of that. Now another one, the seventh rule, it says a raised to n over n equals the nth root of a raised to n. Now these two have relationship. The difference is that this is 1, it is unity. So it is not visible here, although we know there is an invisible one there. Okay, so it is the same thing as this, only that in this situation now, the numerator of this index is a value that is non-1. That what is from 2 and above, that is non-1. When it is 1, it is like this. It is not what shown because the numerator is what? 1. But when it is a value that is non-1, for instance, if we have example 8 raised to the power of 2 over 3, like this now. So what will be there is 3, 8 raised to the power 2. The numerator comes here. Okay. The same way, if we have 10 raised to the power of 4 over 3, what we'll have is 3 10 raised to the power of 4. Okay, so that is it. Whenever we have the one that is non-1 as the numerator of the index, it becomes the power, okay, to the root of the denominator of the index. Okay, so that's the 7th rule. Now the 8th rule is a raised to power minus m over n equals 1 over a raised to power m over n. Remember this negative rule, which is this part, 1 over a raised to power n, is also applicable here. Okay, a raised to power m over n equals 1, since it is what, negative, over a raised to power m over n. For example, if we have 8 raised to power minus 2 over 3, the same thing as equal to 1 over 8 raised to power 2 over what? 3. Okay, if we want to simplify this further, equal to, remember it is 8 raised to power 2 over 3. Okay, so it can be seen as 1 over cube root of 8 raised to power 2. So which is equal to 1 over. Now the cube root of 8 will give us 2. That's 2 raised to power 2. The cube root of 8 is 2. So 1 over 2 raised to power 2 will give us 1 over what? 4. Okay, to give us 1 over 4. So those are some of the laws of what? Of indices. Those are some of the laws of indices. Okay, so those are basically some of the laws. We have many other laws for advanced level, but these are basically some of the laws that can be used in solving some questions. Now let's see a typical example, typical questions. Like say we should simplify 16 raised to power 1 over 2 times 8 raised to power minus 4 times 3 raised to power minus 2 over 3 divided by 81 raised to power 2 over 3. Now we have solution. And we have 16 raised to power 1 over 2 times 8 raised to power minus 4 times 3 raised to power minus 2 over 3 divided by 81 raised to power minus 2 over 3. Now what we should do whenever we're solving a question like this, ensure you express them to have the same base, okay, and apply the knowledge of these laws to it. Now in this now, 16 and we have 8 here. Now we can express this as regards the base of 2. 16 can give us 2 raised to the power of 4, because 16, 2 raised to the power 4 is 2 times 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Okay, so 16 can be 2 raised to the power 4. Now this 1 over 2 can be times 1 over 2 times 8 can be expressed as 2 raised to the power 3. Okay, multiplied by minus 4. Okay, that 16 is 2 raised to the power 4 times this 1 over 2 times 8 is 2 raised to the power 3 times this. Then we have multiplied by, we have 3 here, raised to the power minus 2 over 3 divided by 81. Also, we can express it in terms of 3. 81 can be 3 times 3 times 3 times 3, that's 3 raised to the power 4. And 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. So it will be 3 raised to the power 4 multiplied by minus 2 over 3. Okay, multiplied by minus 2 over 3. So if we solve further, the 2 cancelled 4, we have 2 here. So 2 times 1. So what we have here is what? 2 raised to the power 2 times 2 raised to the power 3 times minus 4 will give us minus 12 times 3 raised to the power minus 2 over 3 divided by 3 raised to the power 4 times minus 2 will give us minus 8 over 3. So you see, we can now simplify. Now 2 raised to the power 2 times 2 raised to the power minus 12. This side, remember this first law, whenever we have the same base and it is multiplication. So we just say 2 raised to the power 2 plus, since it's multiplication we are adding, plus minus 12 times 3 raised to the power. Now since the base are the same, we'll take and subtract their index since the base are the same. So minus 2 over 3, remember the second law. division when the base are the same. So we have minus 2 over 3 minus 8 over 3. That's index. So I will have 2 raised to power 2 plus times minus is minus. So 2 minus 12 will give us minus 10. Okay? Times 3 raised to power. Now if we simplify here, we have minus 2 over 3. And minus times minus is plus 8 over 3. Okay? So if we simplify further, we'll have 2 raised to power minus 10 times 3 raised to power. Now the LCM of 3 and 3 will give us 3. Now 3 divided by 3 is 1. 1 times minus 2, we have minus 2. 3 divided by 3 here is 1. 1 times 8, we have plus 8. So it's equal to 2 raised to power minus 10 times 3 raised to power. Now minus 2 plus 8 will give us 6 divided by 3. Okay, so we have 2 raised to power minus 10 times 3 raised to power 6 divided by 3 will give us 3 here 1, 3 here 1, and 3 in 6 is 2. So we have 3 raised to power 2. Okay, so we have 2 raised to power minus 10 times 2 raised to power 2. So 2 raised to power minus 10 times 3 raised to power 2 will give us 9. As 3 times 3 as what? As 9. So now 2 raised to power 10. Remember this law, the inverse law, where there is negative. So it will be 1 over 2 raised to the power of 10 times 9. So our final answer can be 9 times 1 will give us 9 over 2 raised to the power of 10. That is the answer to that. Okay? So you can play it back to actually see what we have done. Okay? So that's how to solve the first question. So don't forget, we are on YouTube, TikTok, Instagram, and Facebook. Ensure you join us there. Okay? And subscribe also. So that is how to solve the indices question. Okay? So because of the space of this CD, you can ensure you join us in our YouTube for more. Okay? Because we are limited to time that we post more often. Okay? So that is how to solve the first one. So let's see the second one. And the second one we have II 27m plus 2 times 4m divided by 6 raised to power 2m. Okay? Now 27m plus 2 times this. Now 27 can also be expressed as 3 raised to power 3 into m plus 2. Okay? Times 4 can be expressed 2m divided by, now our 6 can also be written as 2 times 3 all raised to power 2m. Because 2 times 3 is what? 6. Okay? Now if we solve further, we have 3, opening this bracket, 3 times m will give us 3m plus 3 times 2 is 6 times 2 raised to power 2m divided by, now since 2 times 3 all raised to power 2m, we can actually split it as 2 raised to power 2m times 3 raised to power 2m. Okay? So that is the case now. At this point now, 3 raised to power 3m plus 6 times 2, all divided by 2 raised to power 2m times 3 raised to power 2m. So we can collect like terms to ensure that we collect the ones that they have the same base with. So if we have 3 raised to power 3m plus 6, now from this part they are divided. So bring this 3 raised to power 2m So they can be together because of the base. Remember, this is dividing this. So what is coming here is divided by 3 raised to the power 2n times. Now we already have our 2 raised to the power 2n, 2 raised to the power 2n, also dividing this. So it will be divided by 2 raised to the power 2n. Okay, so if we solve further, we'll have, now since these two are the same, remember our second law, but in division, we'll take the base and subtract their powers. So we'll have 3 raised to the power, we have 3m plus 6 subtract 2n, okay, times 2 raised to the power, since these two, take 1, 2n minus 2n. So, if that's the case, now we have 3, these come together, 3n minus 2n plus 6 times 2 raised to the power. 2n minus 2n is what? 0. So we have 3 raised to the power of 3n minus 2n will give you n plus 6. Okay, so n plus 6 times, now 2 raised to the power of 0. Remember, anything raised to the power of 0 is 1 times 1. So 3n plus 6 times 1 will still give us 3n plus 6. So that is the answer to the second question. Okay, so that's how we solve this. Now that is laws of indices. We still have many other solutions, but because of the limited space for this, so ensure you have subscribed to our channel, the King's Tutor, so that you learn free there. Okay, the King's Tutor, on YouTube, Instagram, Facebook, so that you see more questions on indices and other math questions. You will not be limited to it. Okay, now let's see the next topic in this video, and let's go to the next topic.